In this session, we want to start considering objects, object-oriented objects. So I'm going to come back to diagrams.net with this diagram that I've been using of a bank account class. Now, this is a description, a model of what all bank accounts have in common. But keep in mind that there is actually going to be actual bank account objects. Okay? In other words, an individual person might have several bank accounts. An actual bank might have thousands of bank accounts, individual ones, each with its own value for the owner, its own value for the balance, and its own value as to whether it's active or not. So again, we're describing so far the classes, the kinds of things that exist in this system. So let's look at now, how would we actually create an object? How would we actually use one of these things? And before I answer that, we need to consider one more thing, and that is computer programming, software development didn't originate thinking object-orientedly. Okay? Originally, we didn't have classes and objects. We just had these activities, these procedures, these actions or behaviors that we would do. So if you think of like some of the older programming languages like a C, for example, where everything was a procedure or a function and some variables. And that's great when our systems are relatively small and you can kind of wrap your head around the whole thing. But as our models grew and as our software became more and more complex, it becomes harder and harder to keep track of, what variables go with what functions kind of thing. And so one of the guiding principles of object-oriented design was this notion of encapsulation, where we can take the variables and the functions or procedures that act upon them and encapsulate them, put them into one capsule, into one group, one container that we call a class. Now, because of that, there's going to be this question about, where does the first object come from? How do we get the first object? Even our operating systems today are still not really object-oriented. So that means there has to be some way of creating the first object, and then we can create all the others from there. And since there has to be some way of doing that, it sounds like, there's some kind of method or function or procedure before we ever do any of this class object-oriented stuff. So all that to say, that there is going to be one behavior, activity, that is not a part of any class. So remember, I'm going to shrink this up here and say that we said that when I named this activity diagram, I named it with the class name and then the method name. So we know that. So there's going to be one, and hopefully probably only one, activity in our model that has no class. And it's just the start. In fact, I'm going to call this start. Okay. And it's in this first initial starting method, activity, function as to where we'll create the first object. So when we do that, we're going to have an action here, and we need a name for the object. Okay. Well, actually, technically, we'll have anonymous objects later, but initially I'm going to say that what do I want to call this bank account? I'm going to call it mine. Terrible name. And then I'm going to use our assignment operator. So again, this is not the equal sign that you're used to. This is the assignment operator. This says, okay, do whatever is on the right-hand side and assign that to what's on the left-hand side. And so most object-oriented languages have this idea of a keyword like new or something, where we're saying, okay, mine is going to be a new portfolio. And we would say then that we're newing up a portfolio object called mine. The other terminology we like to use is we're saying we're creating an instance of portfolio, or we would say that we are instantiating a portfolio object called mine. This is some of the terminology we use. And so what that really means for the machine is that it's going to figure out how much memory does it take to store a portfolio, the data, all the data for a portfolio, and then it's going to allocate that memory. It's going to reserve it for this object. Again, that's why the type is so important, because portfolio is a type, so it's saying, okay, how much memory do I need for a portfolio type of thing? Okay, and I'm going to reserve that, and mine, the name of the variable, if you will, is going to be a reference to that memory location, to that region of memory, the first address of that memory where this portfolio object is stored. And so then what would happen is if I said yours is assigned a new portfolio, then it's going to allocate, that's going to bug me, is going to allocate another chunk of memory, same size, but another chunk of memory, and point to it, refer to it by the name of yours. And that's how each one of these can have a separate bank account. The value of the bank account property for mine is different because it's in a different memory location than the account property for yours. And of course, then the portfolio object would probably create a new bank account.